Okay, hi guys. So today we are going to solve this problem. That is the problem number 128 and the name is longest consecutive sequence. So first of all, longest we need to find the maximum length of what? Of a sequence. And the sequence elements have to be consecutive. For example, 1, 2, 3, 4, 5, and so on. Then natural numbers like 6, 7, 8, 9. These are consecutive numbers because the upcoming number is incrementing by the previous value, right? So the fifth so 4 has a next value as the current value plus 1, that is 5. But 1, 2, 3, 5 is not a consecutive sequence. Why? Because 1 is fine, 2 is fine, 3 is fine. But after 3 we were expecting plus 1, that is 4, but now it's 5. So that is not a consecutive sequence. So we need to find these consecutive sequence in the arrays, in the array, and return the maximum length of it. Let's see. So we are given an unsorted array of integer nums and it's going to be integer value. We have to return the length of the longest consecutive element sequence. And let's see this first example. So now I will try to have an example, right? Let's say start with 100. Okay. Do we have 101? We don't. So this is only a first sequence that I have forgot. Let's start with 4. Do I have 4 and do I have 5? No, I don't. So this is only one sequence that I have got. Then let's start with 200. Do I have 201? No, I don't. So this is only again one sequence, 1. So do I have 2? Yes, we have 2. Do I have 3? Yes, I have 3. Do I have 4? Yes, I have 4 as well. So this is another sequence, but I don't have 5. That is why we'll be stopping at 4. Now at 3, do I have 4? Yes, I do have 4, but we don't have 5. So that is why we'll be stopping at 4. Now at 2, so it's going to be 2, 3 and 4. So what is the length offered by these sequences? This is 1, this is 2, sorry, this is 1 again, this is 1 again, this is 4, and this is 2, this is 3. So the maximum length out of these sequences is the fourth. So we'll be returning this as the answer because this is the maximum length. And now let's look at this solution. So I will not be forming the consecutive sequences. I'll just say that by intuition or just by looking at this sequence, you can see that we have two zeros. So we'll be taking 1 0, then 1 because we don't have any other 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. So from 0, 1, 2, 3, 4, 5, 6, 7, 8, we have this sequence, and after that we don't have any remaining elements except 0, and 0 is just a sequence of its own. So the maximum length from this we can have is 9, and the maximum length from this is 1, and the overall maximum for the problem is 9 that will be returned, right? So let's look at multiple approaches. So there will be 3 approaches for this problem, and yeah, so there will be 3 approaches. The first one will be, as obvious, a brute force approach. Let's see how we can use a brute force approach. So we have a function of find, and what this function is going to take is going to take the array and it's going to take the element, and it's going to perform some calculation and return us the boolean value that either that number is present in the array or not. So for example, let's say we have our sequence as 100, 4, 200, 1, 2 and 3, right? Now I will, so this is the first function. This is like a utility function that I have created, find, and the main function we will have our pointer. We will have a pointer starting from 0 and all the way to the, and traversing up till the last index of the array, that is n minus 1. So from 0 it will take a look that do we have, it will run a while loop. So from each and every like this index, it will run a while loop that do we have the next consecutive element of the current element. So the current element is 100. Do we have 101? So I'm going to go in, so I'm going to use this function and I will say that in the nums array, do we have 101? And it is obviously going to return me false because we don't have that. So because we don't have that, it's going to be a false value, and we are not going to increment our length, and length is again as 1, and we are simply going to increment our I. And from 4 we are going to find that do we have 5? No, we don't have 5. So I'm going to increment 200. At 200 we don't have 201. And at 1, now I'm at 1. At 1 I do have 2. Okay, so the length is incremented. So it was 1 initially, now it is 2. So the length was 1 initially and now it is 2. And let's see, do we have 3? Yes, we do have 3. Now the length is 3. Do we have 4? Yes, we do have 4. Now the length is 4. So this is a one sequence where 1, 2, 3 and 4. These are the consecutive sequence elements that I have found in the nums array forming this sequence. Now let's see, do we have, now increment the pointer to 2, and let's check that do we have 2 and 3 and 4. And it's going to be obvious that for 2, if we are starting from 2, then this is going to be a sequence, and we don't need to perform this calculation again, because after 4 we are not going to find anything. And this length, because this is a subsequence of the main sequence that we have found earlier, is always going to be smaller than the previous sequence. So that is why we don't need to compute this. I mean, this is a brute force method, and in a coding part this will be computed, but just like explaining point of view, I don't want to explain that why do we have to take it out and process it further on. So this is the sequence that we have found, and the maximum length that we have stored is 4, right? So 4 is our answer. That is why 4 is our answer. Now let's calculate the time complexity. So just a minute guys, I have a very important phone call. Yeah, so this is the brute force approach, and yeah, so in the brute force we can see the time complexity will be very high, because this find function is alone going to take linear time. And then when we are iterating, because it's an unsorted array and we have to iterate on each and every element, so it will take, the linear traversal will take, as obvious, n time. And one other thing which you will only find out if you are coding, that you will have a while loop in order to identify this sequence, right? Because when we are at 1, we will be having a while loop that do we have 2, do we have 3, do we have 4? That is the one incremented element of the current value, do we have that element? So we need to have a while loop, and that while loop will be using the find function, which is why this sequence formation is also going to take linear time. And when we will see this will be like one for loop, then another nested for loop, and a condition that is using in the for loop, which will take n time. So it's like order of n cube time. This is the time complexity, and the space, so this is the time complexity, and the space complexity will be constant, because we are not using any data structure or any memory auxiliary space to store the numbers. We are using just the simple unsorted array that was given to us. Now another approach, and it's a pretty optimized approach, and a very good approach, and as compared to the brute force, it's a huge optimization that we can do by sorting. So we have 100, 4, 200, 1, 2, 3, right? After sorting this array, this is going to be 1, 2, 3, 4, 100 and 200, right? Just to make things more difficult, I will take a 2 again, and now I have 1, 2, 2, 3, 4, 100 and 200. Let's see how we can deal with this. So I will put a pointer, or I will start iterating from the first element, and when I'm iterating from the first element, I will take a look that do we have, like, the other element, is it the incremented one or not? So when I'm at 1, I will find that I have 2. So the length is now incremented, the condition is satisfied. So length is from 1, now it has become 2. And when I am at 2, so this is a tricky part, because we have already analyzed that after 1 we have 2, we have gotten our 2, right? We don't need an extra 2. That is why we will skip this one. We are not going to reset our length pointer or length variable or anything like that. We are just going to continue with the iteration or the traversal. And when I'm at 3, my current value was 1 and then 2. Now my current value is 2 and the new value that I am encountering is 3, and it's the plus 1 of the current value, so that is why it's also accepted. And the current value, the new current value is 2 and the value is also incremented, length is also incremented, that is 3. And at 3 I have 4. Again the condition is satisfied, the current value is 4 and the length is also incremented. After 4 I have 100. Nope, that's not the case. Now we don't have, the current value will be changed but the length will be reset. So now the length is 1, but mind it, the maximum length will be stored in some variable that has a record that we have reached this maximum length of 4 in some, or in some sequence of our traversing. So now the length is reset to 1. Length is reset to 1, and after 100 do we have 101? Nope, we don't. So the current value is going to be 200, the new value, and length is again going to be reset to 1. It is already 1. And at 200, after 200 we don't have any 201 because that's the last element. So we have, this means that we have basically exhausted our nums array, and whatever the max length that we have recorded is our answer, and that is correct. Our answer is 4. Now you must be wondering that from 2 we can have our own sequence. But if so, one thing to notice in the sort part is, if we have a sequence like this 1 2 3 4, that is our longest consecutive sequence, and if I start from this 2, because I'll be certain about one thing, that 4, after 4 we don't have anything. So this is only going to be this sequence, and if I start from 3, this is only going to be this one, right? So this means that if I will take elements in between the longest common consecutive sequence, then their length of the sequence will be lower. I think this is a very common sense, like it's a common sense, it's a concept full of common sense, so I don't need to go deeper into it. Because why this concept is important and why I was stressing on this one, because in the third approach this will be used. So now let's compute the time complexity. So for iteration it will be constant, order, linear time, order of n, and yeah, that's it. And for the sort part it will be n log n. So the overall time complexity will be n log n. And now the auxiliary space complexity, that will again be constant because we are not using any other extra space or array or any data structure to store our elements. Now let's move on to the third and final approach. So third approach is, basically we are going to use a data structure for this, and that is a set data structure. Now a set data structure is a very common data structure, and it's available in, I think, in all of the languages, in almost all of the languages. So if you want to take if you want to study about set, then you can easily find good articles on Geeks for Geeks or even LeetCode. Set is a very old data structure, so there is plenty of information available online. Now let's see how we can do this. So first of all, we have to create a set, and the sequence that originally we have was 104, 200, 1 2 2 3 4, 1 2 2 3 2, right? Now I'm not going to sort them, I'm simply going to store them into the set. After storing them into the set, it's going to look like 1 2, and mind it, this is not an ordered set, it's an unordered set, and I will tell you later on why do we need an ordered set. So while storing them 100, I have stored 100 because 100 was not there in the set. Then I have stored 4 because 4 is also new to the set. 200 is also new to the set. 1 is also new to the set. 2 is also new to the set. But this 2 will not be stored because it's already stored. Then 3 is also new to the set. Now I have stored these numbers, and this is an unordered set. So there are two sets. So the one is ordered and the other is unordered. So in the ordered set, what we have is the insertion. Yeah. So in the ordered set, the insertion, the average time is theta of log of n. And same is for the deletion as well. But in case of unordered set, the insertion average time is constant, right? And that is, and I'm not worried about the deletion. You can check the what is the deletion time in an unordered set. But what I want to say here is that if we have a constant time for insertion, that is like a huge optimization on a brute force method that we were doing, in which we were finding, right? If you remember, we were using a find function which is linearly finding an element in the array, and that function was n complexity, linear complexity. Can you just imagine how much optimization we have done just by using a data structure set? And now from linear time we are using an average constant time, and then we'll be using a while loop, but this time we are going to be little smart um, with the loop. So I'm going to iterate over this set, right? So now I have 100. Now I'm at 100, and I'm going to check that if if this 100 is not an already part of a sequence. And how will I check that? Just by this simple condition, that if set, that is, let's just say set, if set dot find. Now, yeah, now I want to check if this 100 is already a part of a set or not, or a sequence or not. For that I will say 100 minus 1 dot find. I want to find 100 minus 1, and 100 minus 1 is 99. So if I have a 99 in the set, this is like a very similar situation, 1 2 3 4, right? So if I have this sequence and I will try to find a sequence beginning with 2, then it's obviously going to be a smaller sequence than the main sequence. So why shouldn't I just check that if I have a number decremented to 2, that is 1, if I have a number just 1 less than 2, the current element, then the current element will be part of someone's sequence, so I don't have to worry about that number, right? So if I find it, and this is equal to set dot end. By the way, this is a C++ syntax notation of saying that the number that we are finding, this number in this set, and if it is equal to the end, that is that it is not present in the set, that it's not present in the set, then we will perform some operations, and those operations are very simple, that we have to increment our length or decrement our length. It's very much similar to the brute force one, that we'll be resetting our length or doing things like that. So the very first thing will be that we have to set our current num, right? So the current num will be 100. Okay, now the current streak, that is the length, current length that we have, and that is 1. Now I'll be using a while loop, and a while loop will be using a set or unordered set, and it will be finding that do I have 101, do I have 102, or the consecutive elements. And if I don't have a single consecutive element or some consecutive elements, I will just break out of the loop and everything will start in itself, like the I will be incremented this time, and so on. So the time complexity, for this one will be, let's see, yeah, so the time complexity for this one will be order of for the main loop, that is the ith loop, is n, right? Now you will say that in this for loop we have a nested order of n while loop. That means the time complexity will be odd n square, overall time complexity, because finding an element is constant, so we are ignoring it. Not ignoring it because it won't be impacting our main overall complexity. But is it the case that it's going to be n square? No, it's not. Why not? Because of this line. Because of this line, I'm not going to, for example, I have 4, right? Now I don't have 5, so I will just simply increment. Now I am on 200. I don't have 201, I will simply increment or 1. From 1, I will be in my, so from 1, I'll be storing these things that I have a, yeah, so from 1, I will be saying that 1, then I have 2, then I have 3, then I have 4, and my length is equal to 4 now, right? The maximum length has become 4 for me. And when I am on 2, I will see that do I have an element that is smaller than, that is 1 less than the current element, that is 2. Yes, I do have that element, and we are not going to use, and we are not going to perform any processing on that element. We are going to simply skip on 3. And that similar thing happened with 4 earlier. I was not telling you because I wanted to show you the concept of 1. Now with 4, so if I was on 4 and now I will check that does the set contain 4 minus 1 number, that is 3? Yes, it does contain 3. So we will just simply ignore 4 as well. And do it contain 199? No, it doesn't. But it also doesn't contain 201, so we will ignore. And then from 1 we will build this solution which has a length of 4. And at 2 we will ignore again because we have 2, and at 3 we will ignore again because we have 3. Because of set, the time complexity will not be this one, rather it's going to be n plus n, right? Like if you think closely, then it's going to be n plus n of complexity, and this complexity will be n, which is why this set method is so powerful that we have even that from nq, like let's talk about just all of the methods that we have seen till now, that from n cube we have optimized it to n log n, and from n log n we have even optimized it to n, and this is the time. And for space, this will be constant, this will be constant, and for space this will have n because we are using set data structure, sorry, not db, data structure, right? That is why this is going to be n. Space, auxiliary space is n, and time is also n. So these are the 3 approaches that I have shown you. And now let's look at the code for the most optimal one. Yeah. So now the code part. So first of all, if the num size is less than because of the constraints, then we are just simply going to return the size, that is 1 or 0. And now this part. So from this part, we'll be inserting or creating our set with the elements of the nums array. And when we have created our set, then I will initialize the length to 1 because at least there would be single character, and that is a sequence, right? A single character will be accounted for, it's a sequence, and the length will be 1. And the answer variable, I think 0 is fine. I'm not too sure if there will be some conflicts if I have minimum or maximum thing, but I think, yeah, there will be conflicts actually. So yeah, if we have int of minimum, then there will be conflicts. If I don't find any sequence, then I have to return 0 or things like, well, we will look up that later. And then we have this ith iteration loop. Then again, this is the condition that I was talking about. So if I have nums of I minus 1 available in the set, then I'm not going to process that element. But if I don't have any element that is available in, that is nums minus I, the current element minus 1 in the set, only then I will process the further on. So the current number will be the nums of I, the present num, and the length will be reset to 1. And then we are going to look for then we're going to run a while loop, and this while loop will run for nums plus 1, current number plus 1. And if for example we are at 1, now we have find 2, now we have 3, now we have 4, right? the length will be increasing, the current num will also be increasing, that is 1 2 3 4, and the length will be 4 as well, current number will be 4. And now after that 5, now this is going to be 5, but 5 is not in the set, so we will get out of the loop, and answer is going to store the maximum recorded length, maximum global recorded length, that is the length that we have now 4, and initially it was only 1, so that is not 1 actually, yeah 1, so that is why now the length is 4. And after that, if I have, let's say 2, right, but in this set I have one in, but in this set we have 200 4 100 4 200 1 2, right, but if I have 2, then I will see that I have 1, so I will not be entering in this into this set, and I will again just incrementing my I and focusing on the next element. That is why this is an optimized solution. It's going to take n times linear time, although the code seems like that this is going to take n square times, but after dry testing or running a simple dry run on a test case, you can easily identify that it will not take n square time in any case, and it will take linear time. So that's it guys. If you want to see the source code of this one, then I will give a link into the description, and if you want to check out the problem and code the problem yourself, then a link is also provided in the description for the same. So that's it, and thank you for watching guys.